In 12.3 day 1, the first thing we're going to learn about is a reference angle. So a reference angle is an angle formed by the terminal side and the x-axis. Reference angles have to be positive and they have to be between 0 and 90 degrees. Alright, we'll get back to reference angles in a minute. Alright, next thing we're going to learn about is the signs of the trig function values. So remember, the quadrants go quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And so the signs for those, people remember it using ASTC. And some people use the phrase, all students take calculus. Alright, so what does this mean? So for the first 3 trig functions that we learned, this tells you which ones are positive. Alright, so which ones are positive? In quadrant 1, all 3 of these are positive. In quadrant 2, sine is positive, and cosine and tangent are negative. In quadrant 3, tangent is positive, sine and cosine are negative, and in quadrant 4, cosine is positive, sine and tangent are negative. So you might be wondering about the other 3. What about cosecant, secant, and cotangent? Well, those just follow their reciprocals. So if sine is positive, cosecant is positive. If sine is negative, cosecant is negative. So the other 3 just follow their reciprocals. So this trick only works for sine, cosine, and tangent. The reciprocals will just copy. Alright, back to reference angles. So first we're going to sketch the angle. We learned this in a previous lesson. So to sketch the angle, first thing I do is make the initial side, which is the positive x-axis. It is positive 150 degrees, so I rotate counterclockwise. I've gone 90. I need to go to 60 more. I don't want to go all the way to the next line because that would be 180. Alright, so 150 is around here. Alright, so we sketched the angle, but now we have to do something new. We have to find the reference angle. So I'm going to backtrack a little bit. In order to find the reference angle, you have to draw a triangle first. So the way you draw the triangle, you're going to use what's called the bow tie rule. So imagine a bow tie. I'm going to draw a bow tie right here. Imagine a bow tie. If your triangle is in quadrant 1, so the axes go through here. If your triangle is in quadrant 1, you draw the triangle like this. I should say, if your angle is in quadrant 1, you draw the triangle like that. If your angle is in quadrant 2, you draw the triangle like that. If it's in quadrant 3, this is the triangle you draw. And in quadrant 4, draw it like that. So notice all 4 of those triangles use the x-axis, and none of them use the y-axis. So when you draw the triangle, you always use the x-axis and you never use the y-axis. So drawing this triangle, I know I want to use the x-axis and then part of the terminal side. So use the terminal side and the x-axis. Alright, theta always goes right next to the origin, so there's my theta. Next thing you have to do is figure out how big is theta. So in this case, we know we went 150 degrees. If we went all the way to the x-axis, it would have been 180. So it looks like we needed 30 degrees more. So the reference angle is 30 degrees for this problem. Alright, so notice we got that by doing 180 minus 150. That's not always how it's going to work. That's only how it's going to work when your angle's in quadrant 2. Alright, for number 2, let's sketch the angle. Start with the initial side. Then you're going to rotate counterclockwise. 90, 180, got to go 50 more. So around there. Alright, so now I draw the triangle using the bow tie rule. The bow tie rule says use the terminal side and use the x-axis. Okay, where do we put theta? We always put theta in the triangle close to the origin. So how big is that angle? So notice that angle is part of the spiral. On number 1, it was outside of the spiral, but this one overlaps with the spiral. So we had gone 180, and then how did we get to the end? We went 50 more. So this angle has to be 50. So comparing number 1 and number 2. For number 1, we did 180 minus the given angle. But for number 2, we did 230. We took the given angle and then we subtracted 180. So it'll be different depending on what quadrant you're in. Alright, on number 3, we're going to be in quadrant 4. Start with the initial side. Rotate 90, 180, 270. Looks like we need to go 20 more. Alright, drawing the triangle using the bow tie rule. Use the terminal side and use the x-axis. Theta is always right next to the origin. Right, so how big is that? It looks like, so for this part I went 20 more. So I think to close that we would need 70 degrees. So theta, the reference angle, equals 70 degrees. And I'll write that a little nicer down here. Alright, number 4. Number 4 is negative, and it looks like it'll end up in quadrant 1. Start with the initial side, which is the positive x-axis. Rotate clockwise. Negative 90, negative 180, negative 270. Right, so if I've gone negative 270, from 270 to 320 is 50, so I need to go 50 more, a little more than halfway. Now we draw the triangle, terminal side, x-axis, close the triangle, theta is here. Alright, how big is that? Well, if we had gone a complete circle, that would have been negative 360 degrees. So 320 to 360, how many more degrees would that have been? 40 degrees. And remember, reference angles are always positive. They don't care about what direction it was. They just want to know how big is that angle. Alright, number 5 and number 6 are in radians. So because they are in radians, your final answer has to be in radians. Now, it's difficult for me to think in radians. So what I'm going to do is convert it to degrees, sketch it, find the reference angle in degrees, and then convert it back. So in degrees, I need to multiply by 180 over pi. Pi's cancel. 3/4 of 180, that is 135 degrees. Alright, so I'm going to sketch a 135 degree angle. There's my initial side. Rotate counterclockwise 90. 135 is about halfway. Alright, drawing the triangle. I have to use the terminal side, the x-axis, and then close it. Theta goes in the angle closest to the origin. So how big is that? Well, this was 45, so this has to be 45 as well. So theta is 45 degrees, but again, we have to answer in radians. So I'll do the work here. 45 degrees times pi over 180. That equals, so 45 over 180, that is 1/4. If you take 180 and divide by 4, you get 45. So this is going to be pi over 4. Okay, again, it's difficult to think in radians, so I'm going to convert it to degrees. Alright, I'm just going to remember that pi equals 180. So imagine this is 180. 180 divided by 6 is 30. 30 times -5 is -150. Alright, let's sketch -150. Initial side. -90. 60 more. Drawing the triangle. Terminal side. Theta goes near the origin. Alright, so how big is that angle? Well, so I went 90. Then to get to 150, I went 60 more. So that angle has to be 30. Converting it to radians. So remember, pi is 180. Pi is 180. How do you turn 180 into 30? Well, you divide by 6. So because this is 180 divided by 6 in radians, that's pi over 6. Okay, remember what I just taught you. ASTC. This only applies to sine, cosine, and tangent. So in quadrant 1, all 3 of those are positive. In quadrant 2, sine is positive. In quadrant 3, tangent's positive. And in quadrant 4, cosine is positive. Alright, so this is a little different. They're going to give you a coordinate this time. So make a rough sketch of where that coordinate goes. So 3, 4 is around here. Then you're going to draw a triangle using this point. You need to remember to follow the bow tie rule. So first thing I do is go straight to the origin. Remember to use the x-axis and never to use the y-axis. And then close the triangle. Theta goes near the origin. And now you have to do all 6 trig functions. Alright, so first thing you have to do is label the lengths of the triangle. So this bottom distance is 3. This vertical distance is 4. Using the Pythagorean theorem, you know the hypotenuse is going to be 5. Alright, let's label these sides. SOHCAHTOA. So from theta, this is opposite, this down here is adjacent, and this is hypotenuse. Okay, so sine theta, sine is opposite over hypotenuse, and cosecant is the reciprocal of that. Cosine is adjacent over hypotenuse. Secant is the reciprocal of that. Tangent is opposite over adjacent, and cotangent is the reciprocal. Alright, notice all 6 of these are positive, and in quadrant 1, everything is supposed to be positive. Alright, for number 8, we're in quadrant 2. So I'm just going to say this is negative 12. For 5, I won't go up too high. So I want the point negative 12, comma 5. That'd be around here. Drawing the triangle using the bow tie rule. So go straight to the origin. Use the x-axis and close the triangle. Theta goes here. Alright, so this length is 12. This length is 5. Using the Pythagorean theorem, or Pythagorean triples, we know it's a 5, 12, 13 triangle. Alright, so we have to find all 6. Let me write them beforehand. Sine theta, cosine theta, tangent theta, and their reciprocals. Cosecant of theta, secant of theta, and cotangent of theta. So in quadrant 2, remember ASTC, we are in quadrant 2, so sine is positive, which means cosine and tangent are negative. If cosine and tangent are negative, so are their reciprocals. Okay, so we have to label our sides. This is opposite of theta. This is adjacent to theta. And this is the hypotenuse. Alright, so sine is opposite over hypotenuse. Take the reciprocal for cosecant. Cosine is adjacent over hypotenuse. So secant has to be negative 13 over 12. Tangent is opposite over adjacent. And cotangent adjacent over opposite. Alright, so we did one in quadrant 1, one in quadrant 2. Looks like number 9 is in quadrant 3. So negative 4 comma negative 4. Let's plot that point. I'll call this negative 4 and this negative 4. So the point would be around here. Drawing the triangle. Go straight to the origin. Use the x-axis. Close the triangle. Theta goes near the origin. So this length is 4. This length is 4. We have to use the Pythagorean theorem. 4 squared plus 4 squared equals c squared. 16 plus 16, 32 equals c squared. Square root both sides. C is going to equal 4 radical 2. So the hypotenuse here is 4 rad 2. Okay, so we have to write the 6 trig functions for angle theta. Now, one thing I suggest is notice all three sides are divisible by 4. If you reduce them now, then you won't have to reduce 6 times for all 6 trig functions. So I can divide this side by 4 and it becomes 1. Divide that by 4, it's also 1. Divide the hypotenuse by 4 and you just get rad 2. So the sides are 1, 1, and rad 2. From theta's perspective, this is opposite, this is adjacent, and this is the hypotenuse. So writing out all 6, we're going to find sine theta, cosine theta, tangent of theta, and the 6 are the 3 reciprocals. So that's cosecant of theta, secant of theta, and cotangent theta. Alright, remembering what quadrant we're in, A, S, T, C. We're in quadrant 3, so tangent's positive. If tangent's positive, sine's negative, cosine's negative. Their reciprocals are negative. Okay, so we want to do opposite over hypotenuse. 1 over rad 2. You're not allowed to leave a radical on the bottom, so multiply the top and the bottom by radical 2, and it's going to stay negative. Negative radical 2. And if you multiply the bottom by radical 2, the radicals cancel. Alright, cosine's going to have the same answer because it's also 1 over radical 2. Opposite and adjacent were the same thing. Tangent's going to be opposite divided by adjacent, so that's 1 divided by 1, which is 1. Alright, that's the easiest one to take the reciprocal of. The reciprocal of 1 is 1. When you find cosecant and secant, don't flip the final answers. Flip these ones. That way you won't have a radical on the bottom after you flip it. So that's negative rad 2 over 1. Don't need to write the 1. And secant's the same thing. Alright, number 10 is in quadrant 4, which we haven't done yet. We want 2 on the x and negative 6 on the y. Drawing the triangle, you go straight to the origin, use the x-axis, and close the triangle. Theta is near the origin, and find the 3 sides. So this was 2, this is 6, Pythagorean theorem, 2 squared plus 6 squared equals our hypotenuse squared, 4 plus 36. So c squared equals 40. What's the square root of 40? 40 is 4 times 10. We know 4 has a square root of 2, so the 10 stays inside. 10 doesn't break down because it's 2 times 5. There are no pairs there. So the hypotenuse is 2 radical 10. Remember, reducing it at the beginning will save you from reducing it 6 times. So divide this by 2, you get 1. Dividing the hypotenuse by 2, you just get rad 10. So 1, rad 10, and this is going to become 3. Alright, the 1 was adjacent because it's touching it and it's not the hypotenuse. 3 is on the opposite side. And the one we found with the Pythagorean theorem was the hypotenuse. Reciprocal of sine is cosecant. Cosine goes with secant. And tangent goes with cotangent. Before we start writing those, let's figure out which one is negative. I should say which ones are negative. So A, S, T, C. Cosine is positive. So sine's negative, tangent's negative, cosecant is negative, and cotangent's negative. So sine is opposite over hypotenuse. Multiplying top and bottom by radical 10, we get 3, I should say negative 3 radical 10 over 10. Okay, let's do the reciprocal now. Flip the fraction before we simplified it, you get radical 10 over 3. Cosine is adjacent over hypotenuse. Multiply top and bottom by radical 10. You get radical 10 over 10. Okay, flip the first step, and you get radical 10 over 1. For tangent, we're doing opposite over adjacent, so that's 3 divided by 1, and it's negative. The reciprocal of negative 3 is negative 1/3. So the key thing to remember is think about what quadrant you're in, and that'll tell you which of these are positive and which are negative. Alright, that's it for this lesson.